Hi there, in this video we will see how to create DTM digital terrain model and DSM digital surface model using point cloud data. For the sake of this video, I have downloaded some sample point cloud data that you can also find on the website given in the description. Let us head over to the website and see. So this is the link. If you visit this link, you will see the last folder in which there are a lot of files available, and along with this there is also a shapefile available. So I would recommend you to also download the shapefile and then whatever last files that you are interested in. In my case, I have only downloaded 1120.las, but if you want to download others, feel free to go ahead and download it. Now let us try to bring that file on the map, and this is how it looks like. As you can see, this is already classified for us, which is absolutely important if we want to calculate DTM and DSM. Now the way we think about how DSM and DTM are calculated are as follows. When we want to do DTM, we have to have ground related points. So the points such as ground and water will help us to make the terrain model of the earth, whereas all other points will be responsible to make the surface model. That means while dealing with this point cloud data, we will have to separate the classifications and then use them. And finally, we will end this video by also doing CHM. CHM stands for canopy height model. That means you take DSM and then you subtract DTM from it. Whatever is left is actually only those locations or only those areas where you have height which is greater than DTM. Now let's see that in action. Now to go ahead with this, we will head over to our terminal, go to the folder where I have my own data and open it in VS Code. Now let me open this in VS Code one more time, and there you go. So I have a data folder in which I have this 1120.las and my shapefile as well. Now before we write the code, let us also have a look at this shapefile. So I'll simply bring this shapefile, and as you can see that this shapefile actually represents the grids from the website for which the data is available. In our case, we have simply downloaded the data of 1120 tile, but in your case you might have downloaded something else and that will still fall on this shapefile only. Now we can just simply go to the properties of this and see what is the projection of this, because many times you will see that last file will not contain projection information, and if you don't know projection, then it will be very hard for you to create any kind of analytics or data from it. So after looking at this, I know that the projection of my last file is going to be EPSG 26985. Alright, now it's time for us to go to our VS Code one more time. We will start by creating a virtual environment. In my case, I already have a virtual environment, but if you don't have it, you can simply go and type python 3 -m and your virtual environment will be created. Now we will activate this environment and start by installing all the packages that are required. Now the first package that we require is obviously notebook, because we are going to create Python notebook. If you are not going to create notebook, then it's fine. So I will also create a notebook meanwhile over here in my folder with the name digital elevation models.ipynb. There you go. Now we will do all the required installations. The first thing that we need is laspy. Then we need rasterio, and then we need scipy, and finally numpy. Alright, we have all the things that we need. I will also upgrade my pip. Now let us see if all the installations are done correctly. So I will simply do import laspy, and I will run this, and I will select my environment variable. Alright, it looks like it's working. Then I will do all other imports that are needed. So I will import numpy, I will import rasterio, and also one more feature from rasterio known as from bounds. I will let you know why we need it shortly. And finally, we also need something from scipy. So from scipy dot spatial, we need to import KD tree algorithm. Alright, for now this is okay. Now let us start by defining some variables. So first variable would be the CRS itself. So I will put it as my CRS is equal to EPSG 26985. I'll simply confirm this one more time by going to my QGIS, looking into properties and 26985. So we are correct. And then the path of my last file. So path of my last file would be data and then 1120.las. So data slash 1120.las. Now if you are going to deal with LAZ file, then you will need to install a plugin for LAZ for laspy. If you want to do that, let me know in the comments. I'll make another video where we deal with LAZ file. Alright, these are the two variables that we need at the moment. Now let's start by defining functions. So for the sake of saving time, I will simply copy these functions from my another file and paste it over here. So the first function that we need is read last bounds. So imagine that we will pass our last file path to this function, and this function will tell us what is the minimum x, minimum y, maximum y from this particular last file. Now this is very important for us because this will set the bounds of our DTM, DSM and CHM. The next function that we need is create grid from bounds. So these bounds that we calculated above will only give us the minimum and maximum of x and y. We need to create grids in between them at a specific interval, and that interval will be defined by the resolution. I am going with 0.1. So the lesser the resolution, the denser our grid will be. If you have a big area to deal with, you can also fix the resolution at something like 1 or 2 meters or something like that. In our case, we will go with 0.1 meter. Now the next function that we need is interpolation of the points. So I will simply copy this function and paste it over here. If you want to get all this code, you can find the link of the GitHub repository in the description of this video. Alright, so in this case, we will get x, y, z from the last file. Then we will take the grid x and grid y that we have calculated in the above function, and then we will try to calculate the z, that means the height for our entire grid x and grid y. To do that, we will actually take the height from our last file, and then we will use the nearest neighbor methodology to find out the height at the relative grid x and grid y location. So as you can see, we will start by creating a one-dimensional array from x and y. Then we will get our flat grid points, and then we will convert z into numpy float 32, and then we will use this KD tree algorithm to actually get the relative nearest neighbor z value, and then we will simply export this z value. Then we need to write save raster function. Now this is important if you want to export your data as a TIFF file. So over here again we will take the file name that we want to store. We will take x, y and the data. Now here x and y will be very important because they will define the bounds of our application. Now this is the reason why we are using this from bounds method from rasterio, because if we don't use it, the general way of representing data is x goes from 0 to infinity and y goes from 0 to infinity. But if you see any map, the 0, 0 is always at the bottom left, and to define that bottom left, that is where we are going to use this from bounds function. And finally, we will define our filter CHM function. So in filter CHM, we will simply ask for DSM and DTM, and we will subtract DTM from DSM. Now on top of that, I have also given one more parameter, that is minimum height. So even after subtracting DTM from DSM, if you still want to give a height parameter that okay, I only want all the features which are greater than certain height, that is what you can define over here. And then that's all. These are all the functions that we need. Now let's see all of these functions in action. So the first thing that we are going to do is load our last file. right? So I have written a different variable name, so I will copy this and paste it over here, and there you go. So our last file is loaded and we have mean x, mean y and max y value. Now let us try to see if these values are correct. So as you can see, the mean x is 389400. Now if I go to my QGIS and turn off this layer, if I hover my mouse over here, you will see at the bottom over here you will see the coordinates. I'm not sure if these are visible or not, but as you can see we are getting 389398, which is very close to 389400, and over here we are getting 390200 and we are getting 390199. So again, which is very much accurate. So now that we have loaded the last file, it's time for us to create the grid based on this minimum x and maximum x, minimum y and maximum y. To do that, we will simply call our create grid function and we will pass this mean x, mean y, and we will keep resolution as 0.1. There you go. Our grid for x and y are created. Now it's time for us to filter our point cloud data so that we know what data will go in the creation of DSM and what data will go in the creation of DTM. So as we discussed earlier, for DTM we are only interested into using ground and water points, and for DSM we are interested into using everything but ground and water points. So to do that, we will separate our points. So we will simply write it something like this. So we are filtering ground points by giving last classification either as 2 or as 9, and then all non-ground points will be everything other than these ground points. Alright, and now it's time for us to generate the Z value for this DSM and DTM. Now to do that, we are simply using our interpolate function, and for our DSM we are using non-ground points. So you can see that I am using x from non-ground, y from non-ground, z from non-ground, and then the grids that we have created. And then for the DTM we are using ground points. Now this will give us the Z value of DSM and DTM. Now this might need some time since it uses some special functions in between, such as this KD tree. And if you want to learn more about KD tree, please check out the description where I have posted the link of this entire algorithm. Great, our interpolate points are ready with us. Now it's time for us to export this data. So to export, I will simply use our save raster function. I will give the name dsm.tif for our dsmz and dtm.tif for our dtmz. So if you understood it correctly, we took the grid x and grid y from numpy array based on the resolution. To create these grids, we use the mean x and mean y value, and then now for us to have the z value at those exact grid locations, we use the nearest neighbor method. Now I will simply run this function to export my data. Now here I have used my CRS. Alright, we have our DSM and DTM ready. Now let's try to see them in QGIS. So I'll open my QGIS and I'll simply drag my files over here, and there you go. So we see a DTM where the height is going from 1.16 till 82, and I think this is because we have considered water as well. And as you can see, the least height is over here at the water area. And then similarly, if we try to do DSM, you will see that we get lot of up and downs over here and lot of noise, and we can clearly see the river as the one with the least height. All the trees are also visible over here, and here is a representation of the area where people are living. So if I just turn this off, you will see that there are a lot of houses over here, and also if I turn this off, you can see there are a lot of structures available over here like trees, houses and all, and these are clearly represented by the DSM. Now to wrap this video, we will simply calculate our CHM. So again, when we say that we want to calculate CHM, ultimately we want to calculate the Z of CHM, because we already know the DSM Z and DTM Z. Now the height, what is the minimum height that we want? So in our case, let us go ahead with height as 10 and let us calculate the CHMZ. And now that we have CHMZ ready, we can just export that as well. Alright, now it's time for us to see the CHM in action. And there you go. Now it is representing only the area which has height greater than 10 and it is going all the way up to 45. If I turn off my base map for a second, you will see the entire area. So this is the CHM which represents the area which is greater than height of 10 meter all the way up to 45 meter. This is our DSM and this is our DTM. So this is how you can calculate DSM, DTM and CHM from point cloud data using Python. Thank you.